questions 21 to 25 of the 1999 grade 11 Fermat math contest. How many integers can be expressed as the sum of three distinct numbers if chosen from the set 4, 7, 10, 13, all the way up to 46? So the first thing I want to do is I want to write out all these terms so you have an understanding of what's going on a little bit better. So we've got all these terms, and you'll quickly be able to see that they're just going up by 3. So if this is 4, you went up by 3 to get 7, another 3 to get to 10, and added another 3 to get to 13, and so on, all the way up to 46. And then what they want you to do is take three distinct numbers, three different numbers, and add them up. So let's do the smallest possible sum, which is the three smallest numbers, which are 4 plus 7 plus 10. And that would give you 21. All right? There's several ways of doing this question, but I'm going to do it in the simplest way without any, ends and factoring and all that. That method can be done, but you know what? Just let's stick to the simple stuff here. Now what I'm going to do is I'm going to put the largest sum. What's the largest possible sum I can get by using three different numbers? Well, choose the largest three numbers, 40, 43, and 46. So 40 plus 43 plus 46, and that would give you 129. So this is the smallest, and this is the largest. All right? Now let's keep going here. Let's go for the next one after the smallest. What is the second smallest? Well, it would be 4 plus 7 plus 13. Like that. And that would give you 24. All right? So let's keep going here. How about if I have 4 plus 7 plus 16? What's that going to give me? Well, it's just I've added 3 more, so 27. And so on. 4 plus 7 plus 19 is 30. And if you keep doing this, you'll see that it just keeps going up by 30. The next one will be 33, and so on. All the way up to 129. So you're going to get basically every number that is 21 plus some multiple of 3, all the way up to 129. So 36, 39, 42, ... All right? Those are the possible sums. That's the only way that you're going to be able to get a sum from three distinct numbers, is to follow this pattern. So we just have to add up how many are there. So how do we do that? Well, the first thing is you got to remember that all of these are divisible by 3, right? So if we have 21, 24, 27, 30, and so on, all the way up to ... all the way up to 129. These are all divisible by 3. So if we started, let's say, with 3, so we had 3, 6, 9, 12, 15, 18, and went all the way up to 129, then it would be easy. You just go 129 divided by 3, which is 43. That's how many numbers are between 1 and 129 that are divisible by 3. But we don't have these ones, right? We just have these ones. So you have to subtract these 6. So you get an answer of 37. So I hope that was as straightforward as possible. There's other ways of doing this, and I've done that other way, which is using like a factor of 3 and writing it out with ends and then all that stuff. But I wanted to do it in a simple way in this video. So the answer is 37, and therefore 21 is B. If x squared plus ax plus 48 is equal to x plus y times x plus z, And x squared minus 8x plus c is equal to x plus m times x plus n, where x, z, m, and n are integers between minus 50 and 50. Then the maximum value of AC is, oh boy, where do we start here? All right, so we're going to start with this one up here. For some reason that looks a little bit easier. So x squared plus ax plus 48 is equal to x plus y plus times x plus z. All right? Now, where on earth do I go from here? Right? This is one of those questions that, you know, that there's no standard path. So we have to do a little bit of brainstorming here. What I'm going to do is I'm going to factor it like this. And what are possible factors? Well, one possible factor is 48 and 1, like that. Okay? Now, if I did that, where did the a go? Did the a just disappear? Well, I'm trying to figure out what a is. See, I have no clue. I have no idea how am I supposed to figure out a. So I'm trying to figure out a by giving a possible solution. So I'll expand this out, and this will give you x plus 48x plus 1. And this side remains the same. And therefore we have x squared plus 49 x. Sorry, this was a 48. Don't make that mistake. All right. So now, by choosing two numbers that multiply together to get 48, I was able to create an a. And the a I created was 49. Okay? You see how I kind of manipulated things a little bit? And is this the only possible a? Well, I don't know. They want me to eventually figure out the maximum value of a times c. So maximum value. So whenever they use maximum, minimum, you know, those kinds of numbers, or those kinds of terms rather, I always go for extreme case scenarios. So that's why I chose 48 and 1. So now I'm going to figure out the other extreme case scenario, which is what? Minus 48 and minus 1. That would also give me a polynomial or quadratic that is of that form. So far these x plus y, x plus z, we're not really doing anything with that side, but let's work with this side. So this is going to be x squared minus x minus 48x plus 48. And therefore this is x squared minus 49x plus 48. And therefore in this case, a became minus 49. So here a was 49, a was minus 49. All right, so these are our extreme case values for a, the largest possible and the smallest possible. And now you might say, well, why did you figure out the smallest possible a? I can understand you trying to figure out the largest possible because that's what they're asking for, maximum. But what benefit is there to figure out the smallest possible? Because c could also be negative. And if c is negative and you multiply it by a negative, you'll get a positive answer, right? So here we go. Now we got to figure out c. So here is our formula that contains c. And we've got to figure out, again, extreme case scenario for c. What's either the smallest possible c or the largest possible c, that kind of thing. Now, unfortunately, this is not something that we can factor easily like we did in the previous question. I rather, have to, unfortunately, use the quadratic formula. so shouldn't be too bad. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Right? You all remember that. So we got a plus or minus 64 minus 4c over 2. So this looks like 8 plus or minus, I believe, 2. And we've got 16 minus c over 2. And this is just 4 plus or minus the root of 16 minus c. Okay? So that is our factors, basically. So we can do that up here. So this now therefore factors into x minus the first root, which is 4 plus the square root of 16 minus c, okay, multiplied by x minus the other root, which is 4 minus 16 minus c, like that. And it equals x plus m times x plus n, like that. All right? I hope so far this is making sense. So now compare this guy to this guy. This means that 4 plus 16 minus c, the square root, is equal to minus m. All right? Don't get confused. They're just doing a comparison. So now we can use something that they gave us in the question to figure out c. What did they give us in the question? They told us something. M, n, y, z are integers between minus 50 and 50. All right? So m is between 50 and minus 50. It's not equal to 50 or minus 50, it's between, and they're integers. So what's the largest m can be? Remember, I'm going extreme case scenarios. The largest m can be is 49. So I'll put 49 and see what we get. M is 49, so we have minus m, so minus 49, like that. Let's see if this leads to anything. Minus 49 minus 4 is equal to 16 minus c. Ooh, minus 49 minus 4 is minus 53. And unfortunately, this has no solutions because if you take the square root of any number, it's not going to equal negative. So this does not help us at all. All right, it's okay. Let's go to the other extreme. We tried one extreme, which was 49. What is the other extreme? Minus 49. So we have 4 plus 16 minus c is equal to minus, and we're going to put in the other extreme value of m, which is minus 49. That's the smallest m can be. And let's see what this leads to. So this becomes 49. 49 minus 4 is 45. 16 minus c. All right. Square both sides. 45 times 45 is 2025. And therefore c is 16 minus 2025, which is minus 2009. All right. So we have a c, extreme case c, and we've got two values for a, and we have to figure out the maximum value of AC. All right. So a is 49 and minus 49, right here. 49 and minus 49. So a is 49 minus 49, and we've got an extreme case scenario C of minus 2009. So now we have to figure out AC. Okay. Well, let's do the first one. 49 times 2009 is minus 98441. And then the next one, 49 times negative 2009 is 98441. So this is easily the largest value for AC. All right, so I hope you understood how I kind of worked through this. So 98441 is choice E. The sum of all values of x that satisfy this equation is, so this equation is x squared minus 5x plus 5 to the power of x squared plus 4x minus 60 is equal to 1. All right. So how do we approach this? For the sake of simplicity, I'm going to call this A, and I'm going to call this B. So we therefore have an equation of this form. A to the power of B is 1. Okay? Now, when can this be true? Well, the first scenario is if A is equal to 1. If A is equal to 1, it doesn't matter what B is, A to the power of B will be equal to 1. So that's scenario number 1. Scenario number 2 is if B is equal to 0, right? It doesn't matter what A is. If you put anything to the power of 0, it will be 1. Okay? So that's scenario number 2. And I believe the last scenario is if A is equal to negative 1. And is important, B must be even, right? Because you have negative 1 to the power of an even exponent, like let's say 2, it will be 1. If B is odd, it will not be 1. It will be, for example, negative 1 to the power of an odd number will be negative 1. So for scenario number 3, A has to be negative 1 and B must be even. All right, so let's go work through each of these one by one. So let's do scenario number 1 first, which is A is equal to 1. And this is our A right here. X squared minus 5x plus 5 is equal to 1. Okie dokie. So x squared minus 5x plus 4 is equal to 0. And does this factor? I think it does. X, 4, 1, minus, minus. So x is equal to 4 and 1. So we've got 2 x's so far. Now let's go to scenario number 2. And what was that? It was b is equal to 0. Okay? And what's b? b here is x squared plus 4x minus 60. And we're going to set that to 0 in order to satisfy the condition number 2. All right, I hope this factors. And I believe it does. 10 and 6? Yeah. Plus minus? Okay, good. So that means x is 6 or negative 10. All right, great. So we got 2 more. And now we've got the final scenario, which is A is negative 1 and B must be even. So what was A again? X squared minus 5x plus 5. Scenario number 3, x squared minus 5x plus 5 is equal to negative 1. And B must be even. So B was x squared plus 4x minus 60. And x squared minus 4x minus 60 is even. Okay, let's work through this. This is a plus, sorry. Plus 4x, right? Yeah, plus 4x. Don't make that mistake. All right, so let's work through here. All right, x squared minus 5x plus 6 is equal to 0. And great, we don't have to do quadratics. I certainly was not in the mood for another quadratic. So this factors into 3 and 2, I believe. Minus, minus, great. So x is 3 or x is 2. But we have to meet this condition also. Both of these cannot immediately be our solutions. This has to be even. So let's plug these in and see what we get. If x is 3, what do we get for b? We got 9 plus 12 minus 60. So that's 21 minus 60, which is minus 39. That is odd. So that doesn't work. So this is no good. And how about x equals 2? What will b become? 4 plus 8 minus 60, which is 12 minus 60, which is minus 48. And that is indeed even. The fact that it's negative doesn't matter. So great. We've got x equals 2. So what is the question asking us? The sum of all values of x that satisfy this equation. All right, so what are all our values of x? We got x is 4, 1, 6, minus 10, and 2. So the sum of all these is 4 plus 1 plus 6 minus 10 plus 2. And that would equal 3. So the sum of all the x's is 3, and therefore the answer is B. Two circles, C1 and C2, touch each other externally, and the line L as a common tangent. All right, right here. The line M is parallel to N and touches two circles, C1 and C3, right there. The three circles are mutually tangent, so those are the tangent points. The radius of C2 is 9, and the radius of C3 is 4. What is the radius of C1? Okay, let's draw this out as large as we can. All right, it's not perfect, but it will do. So this is C1, C2, and C3. So let's start drawing all the things that will help us. So from the center, the first thing I need to do is draw a line all the way to the top to represent the tangent point. And I'll do the same to the bottom. Okay? And I'll need to do that for the other circles as well. These are the tangent points from the center to the tangent point, the lines. And then these tangent points. Now these are straight lines that will go right through the tangent point from center to center. And what else? This one right here also. Okay? And do we need anything else? I think this will also help if we drew lines from the center parallel, like that. That will also help us. Okay, if we need anything else in the future, we can always label it. All right, so let's start labeling these. The first thing I'll do is call the radius of C1 R. All right, we don't know what it is, but we do know the other ones. The radius of C2 is 9. And this is C2 right here. So this is 9 right here. The radius of C3 is 4. So this is 4 right here. And similarly, from here to here is 4 because I just drew lines that are perpendicular, or parallel, sorry. And similarly, this is 9 because this is parallel to that line. And then from here to here is R, So therefore, from here to here is r minus 4. All right? Similarly, from the center all the way down to the bottom is r, and therefore this little guy is r minus 9. All right? At this point, I'm just labeling. From here to here is r, and from here to here is 4. And then this is r, and this is 9. All right? And I believe that should be enough for us to move forward. I think I'll have to label 2 more though. This distance from here to here, all the way on the bottom there, I'll call that x. And this distance on the top, I'll call y. And therefore this is y because those lines are parallel. And therefore this is x. All right, so I hope it's not too messy. I hope you understand. And we can move forward now with a whole bunch of Pythagorean theorems. This is a right angle. This is a right angle. So the first one, the first Pythagorean theorem relationship is with the r minus 9. This one right here, this triangle right in there. So we have r minus 9 squared plus x squared is equal to r plus 9 squared. Okay? It's just a Pythagorean theorem on that triangle. So if we simplify and expand, we've got r squared minus 18r plus 81 plus x squared is equal to r squared plus 18r plus 81. The r squareds cancel, the 81s cancel. X squared becomes 36r when you bring this over, and therefore x is equal to 6 root r. Okay? Similarly, I'm going to do the same thing, but on this triangle up here. And that will, of course, help me figure out y. So we've got y squared plus r minus 4 squared is equal to r plus 4 squared. Right? Just Pythagorean theorem on that triangle right there. Nothing fancy. So we've got y squared is equal to, or rather plus, r squared minus 8r plus 16 is equal to r squared plus 8r plus 16. Looks like the r's cancel, 16's cancel, so we have y squared is equal to 16r, and therefore y is equal to 4 root r. Okay, so we've got 2 very important relationships right there. Now, to figure out the actual numerical value of r, we have to do one final Pythagorean theorem. And that one is a triangle that I need to draw, and it's this triangle right here. This one right here. Okay? So that gives you the following. This side, the hypotenuse right here, is equal to what? 4 here and 9 here. So that's 13. Correct? And then this side here, all the way down, is equal to r minus 4 plus r minus 9. So it's going to get messy, so I'll just write it here. R minus 4 plus r minus 9. And then the bottom there is what? It's x minus y. You see how I got that there? This here is x minus y. All right? So that is our triangle, the final triangle that we need to figure out. So I will draw that again down here to help you understand the quadratic or the Pythagorean relationship. So it was x minus y, r of C1 plus r of C2, which was 4 plus 9, which is 13. And this one on the side was r minus 4 plus r minus 9. And this is our final relationship. And you can verify that up here. I did the same thing. I just wanted to draw this triangle out, this one in here. I wanted to draw this triangle out at bottom of the page so that you don't get confused as to what I'm doing. So now we got one final relationship, and we can solve for the actual numerical value of r. So we have r minus 4 plus r minus 9 all squared plus x minus y all squared is equal to 13 squared. So this becomes 2r minus 13 squared. X and y we know. X is 6 root r and y is 4 root r. All squared is equal to 169. So this looks like 4r squared minus 52r plus 169. And then this is 6 root r minus 4 root r is 2 root r. So 2 root r squared would be 4r is equal to 169. So the 169's cancel. We have 4r squared minus 48r is equal to 0. So 4r squared is equal to 48r. The r's you can divide through. This becomes 4r is 48. And therefore r is equal to 48 over 4, which is 12. So r is 12, and that was what we were trying to figure out in this question. And 12 is, for number 24, choice D. Given that n is an integer, for how many values of n is this expression an integer? All right. So 2n squared minus 10n minus 4, n squared minus 4n plus 3. When is this an integer? For how many values of n? Well, we can start plugging in n's, n equals 1, n equals 2, n equals 3. But the problem is we don't know the boundaries. How much does n go up to? Does it go up to 10? Does it go up to 100? How many n's are we going to plug in? So we have to somehow simplify this. The first thing that comes to my mind is that the denominator is not similar, but somewhat similar to the numerator. So we need to kind of extract the denominator from the numerator. Let me explain what I mean. If you put n squared minus 4n minus plus 3 on the top, like that, you can then therefore put that over the denominator, and that would be equal to 1. And that would help us out. And I think we can do that twice. So plus n squared minus 4n plus 3. And then the n squareds are gone. 4n, 4n. So we need another 2n, minus 2n. And then 3 and 3. So we need a minus 10. I just manipulated the top like that. And then I'll bring this over here. So this becomes n squared minus 4n plus 3 over n squared minus 4n plus 3. The next one becomes the same, like that. And therefore we're left with minus be careful here, 2n plus 10 over n squared minus 4n plus 3. All right? So I hope you understood what I did there. Now, why did I do that? Well, this becomes 1 and this becomes 1. And then we're left with just minus 2n plus 10 over n squared minus 4n plus 3. All right? So we're going to have to work with something, hopefully, a little bit more digestible. Now I'm going to factor out a 2, and that becomes n plus 5, and then the bottom, I hope, factors n 3, 1, minus. Great. All right. So this can be an integer when n is equal to negative 5. That's the first thing that we get from this. So we've got one value. Great. And we also know that n cannot be 3 and also cannot be 1, because that would not give you a real solution. All right, where do we go from here? Now, we do know that this is at the heart of our equation. That's the only part of the equation that we have. And therefore, this is at the heart of our equation. If this whole expression is an integer, then that means that this has to be an integer, correct? And the only way that can be an integer is if the top is greater than or equal to the bottom. I hope that it makes sense to you. Because if the top is less than the bottom, then it's a fraction. Then it's not going to be an integer. So this condition has to hold true. So this hopefully will help us. 2n plus 10 is greater than n squared minus 4n plus 3. Like that. And therefore, what do we have here? N squared minus 6n minus 7 is less than or equal to 0. And if we factor this, we've got n 7, 1, negative, and plus 1, like that. All right. So this expression tells us that n minus 7 is less than or equal to 0. So that means n is less than 7. Okay, that definitely helps us. And if that's true, then that means that n plus 1 has to be greater than or equal to 0, right? Because if this is less than 0 and that's greater than 0, then it'll be negative times a positive, which is a negative. So that means n is greater than or equal to negative 1. So there you go. You got the boundaries, and that's very important. And I think that's it. Now we can just make a table and go for it. I've made a table here of n and our expression in the simplified form. And let's start filling in values of n. Now recall we had figured out that one outlier is n equals negative 5. And when n equals negative 5, this becomes 2 minus 0, which is just 2. And then our boundaries were from negative 1 to 7. So we have to figure out all of the ones that are integers between those boundaries. So for n equal to negative 1, the expression will be equal to 1. When n is 0, the expression will be 2 minus 10 over 3. All right? This expression right here, which is essentially the same as that expression. When n is 1 and when n is 3, remember we have undefined values because they would make the denominator 0. So those we don't need to worry about. When n is 2, this expression becomes 16. When n is 4, the value is negative 4 for the expression. When n is 5, it's 2 minus 5 over 2. When n is 6, it's 2 minus 22 over 15. And finally, when n is 7, the expression is equal to 1. So, for how many values of n is that expression an integer? Well, when n is equal to negative 5, it's an integer. When n is equal to negative 1, when n is equal to 2, when n is equal to 4, and finally when n is equal to 7. So there are 1, 2, 3, 4, 5 values of n that make this expression an integer. And therefore the answer to number 25 is E.